And now we'll move on to our last talk for the day. It's going to be a presentation, a pre-recorded video. And the topic is beyond just carbon removal, enhanced rock weathering as a CDR rock star. And that's carbon dioxide removal, of course. And it's by Sasankh Munukutla, who is the co-founder of Terradot. So if we can cue up Sasankh's video, I think we already have it up. We can play it now.
I'm Sasankh, co-founder of Terradot, a climate tech startup with the mission to accelerate highly impactful gigaton-scale carbon dioxide removal while regenerating Earth. I apologize for not being able to be here live today, as I'm in Brazil on the field, as we're currently having a live deployment of our carbon dioxide removal project. I'm really excited to share more today about the literal and figurative rock star of carbon dioxide removal, enhanced rock weathering. For some context, as many of us know today, as a result of increased greenhouse gas emissions, our planet is set to reach over 3 degrees Celsius of warming above pre-industrial levels. Life at 3 degrees Celsius of warming is really scary. This will lead to multiple global catastrophes, be it severe droughts, flooding, heat waves, impacts on our food system that will impacts on biodiversity as well, that will impact all 10 billion people on their planet and will not enable us to thrive as a population. We have 2 key levers to address this to get to net zero. One is to reduce our existing greenhouse gas emissions, for example, by electrifying a lot of transport and other key industrial processes. And the second lever we have is removing carbon for those emissions that we can't remove or are hard to abate. Today's talk, I'll focus on carbon removal. Per the Intergovernmental Panel on Climate Change, we need to scale up to 10 billion tons of carbon removal per year by 2050 to achieve net zero and to keep warming to 1.5 degrees Celsius to avoid climate tipping points and all those negative consequences I talked about earlier. So even with a lot of efforts first to reduce our existing emissions, we really need to scale up carbon removal. On a positive note, there are multiple negative emissions technologies, NETs, that can help us achieve net zero by 2050. The IPCC does a comparison of some of the major NETs over here, looking at both their cost as well as their potentials. You'll know enhanced rock weathering is right in the center with a pretty decent cost, but also large potential as well. What's not pictured here is, of course, the tens and hundreds of other solutions that are being tested and engineered right now in labs and research centers around the world. And the important thing I want to emphasize is, while focusing on enhanced rock weathering, we do need a portfolio of climate solutions ultimately to have our best chance of reaching net zero. And it's important that all these solutions are worked on and scaled up in parallel to give us the best opportunity as a planet. With that, I'll shift focus to the CDR rockstar enhanced rock weathering. What is enhanced rock weathering? Well, first of all, Earth has a natural carbon cycle already that removes more than 1 billion tons of carbon dioxide annually. This is the silicate weathering cycle. So we have silicate rocks massively present around our planet. When it rains on these rocks, they weather, releasing cations, so think calcium and magnesium. These cations bind with atmospheric CO2 in the water to form bicarbonate, which is a stable form. And this bicarbonate then flows through the groundwater, streams and reverts to the ocean, where it remains stable for hundreds of thousands of years. So it's awesome that this already happens, but the timescale and when this happens is thousands, if not millennia of years, so really geological timescales. What enhanced rock weathering aims to do is simply takes this process and speeds it up. So firstly, you crush this rock into finely ground particles, and thus you increase the surface area by thousands, if not millions of times. And at the same time, you spread this into tropical soil that is warm and wet, and that further accelerates the reaction rate, which effectively allows you to remove carbon in years, and not centuries, if not thousands of years, unlike with the natural silicate weathering cycle. And what really is exciting to me about enhanced rock weathering is a path to a gigaton scale of carbon removal by 2030, specifically in tropical ecosystems. So 75% of ERW potential is actually in the tropics. And what's even more exciting is not only do you have this massive potential, but ERW is actually even faster in the tropics, 3 times faster due to the warm and wet climate. So the combination of a lot of potential as well as fast weathering. And much of the global south actually coincides with tropical ecosystems. And as many of us know here, the global south will be disproportionately impacted by climate change. So there's this real opportunity to take the global south and have them basically scale up this very important climate and be a driver of this very important climate solution, which personally to me is really, really exciting. And when we look at tropical ecosystems, just what's worth mentioning, where areas where there's a lot of impact is Brazil, India, Southeast Asia, also parts of East and Sub-Saharan Africa. So beyond just, of course, carbon removal, and the idea behind this talk is beyond just carbon, enhanced rock weathering has quite a few co-benefits. And to just name a few, you can regenerate degraded lands. You can take land that is no longer productive and remineralize it in the sense and now make it productive. You can reduce the need for synthetic fertilizer and liming, which can often contribute greenhouse gas emissions, but also reduce input costs for farmers as a result. You can make land more productive, improve yield. You can rebuild soil biodiversity. You can alleviate deforestation pressure. 90% of actual deforestation is driven by agricultural expansion. So both by making existing land more productive and also taking degraded land and making that more productive, you kind of eliminate and reduce this need for deforestation. You can improve the retention of water in soil, which makes basic crops more resilient to both droughts and floods. And ultimately, you can foster economic development through scaling up enhanced rock weathering. And what's really particularly exciting to me with enhanced rock weathering is when we look at a lot of the other climate solutions, and again, I want to emphasize it's important that all of these solutions do need to scale. You typically kind of get these trade-offs. So if you either get, permanent removal that's immediately scalable, or you get these important co-benefits, and it's kind of like you have to pick one of these two things. And a quick comparison here, and what excites me about enhanced rock weathering is you kind of don't really have this trade-off with enhanced rock weathering. You get the permanent removal, you get the immediate scalability, but you also get the co-benefits. So it's really kind of cool that you can get the best of both worlds here. And what's also worth noting with enhanced rock weathering is you can actually utilize existing rocks from waste streams, for example, mining waste. So you actually don't have to, mine for new rocks. You can take existing waste streams and kind of make them productive, especially from mines, but also from construction. So that's another piece that makes enhanced rock weathering in my head a true rock star. So on the whole, in summary, enhanced rock weathering is an incredibly impactful global climate solution that we can scale today. We can mitigate climate change, we can make our food system more resilient, and ultimately lead to economic development and prosperity. And it has impact across multiple UN Sustainable Development Goals, which really shows how impactful it can be in thinking about sustainability holistically beyond just carbon removal. With that, I'll shift a bit more to a bit about Terradot. So we're on a mission, as I said, to enable gigaton scale CDR that can regenerate Earth. The status quo is if we continue with business as usual, 90% of the world's soil will be severely degraded by 2050. This will cost the world's economy $23 billion per year, drive global emissions, deforestation, biodiversity loss, and widespread famine. So a lot of multiple global catastrophes. On the other hand, if we deploy durable carbon removal solutions that can regenerate degraded land, we can remove billions of tons of carbon from the atmosphere, prevent deforestation, improve farmer livelihoods, and strengthen global food security. And really, which future we will live in is up to us. Our approach to Terradot is to build a team, science, and technology to unlock the global potential of enhanced rock weathering. So everything starts with their team. We've built out a world-class science team advised by several climate experts from Stanford, where I studied and my co-founder both studied. And we, of course, have also built out a world-class business and technology team drawing from expertise in both academia and industry as well. Everything we do is open science. Our MRV, measurement, reporting, and verification approach is fully open and transparent, so we can learn and build, trust at the speed and scale that climate demands. We're actively participating in several industry groups and sharing our learnings and pushing the industry forward as well. And on the technology piece, we're actually building out a digital platform to enable us to build and coordinate an ecosystem of partners to credibly deploy ERW at gigaton scale beyond 2030. So the important thing with that is that we know that just us as one startup is not going to get to that scale. And what's more important is we activate a whole ecosystem. And we're doing all of this specifically for the tropics, starting in Brazil, where I'm currently at for our deployments. And again, I apologize for not being able to join live. So with our ecosystem, we're continuing to rapidly scale up removal. We've been doing research and development since January 2022. And each of our deployments, basically, were very intentional to de-risk key science, tech, and operational challenges. So we had our first deployment where we aimed to remove about 1,000 tons of carbon dioxide equivalents in October 2023. We're currently doing a 10,000 ton carbon dioxide removal, where I'm calling in live from. And we're de-risking some of our larger scale MRV approaches over here. And all this is, of course, building up to a gigaton of removal per year by 2030, and ultimately then de-risking the idea of bringing this whole ecosystem together and also optimizing deployments as well. So with that, I know I went very deep into one climate solutions, but I also like to kind of zoom out, see the forest for the trees, if you will, and remember the importance of what drives us and drives all of our work. So over here, what you see is an image of planet Earth. It's called Pale Blue Dot by NASA's Voyager that was taken in 1990. And Carl Sagan wrote a whole book about this picture and has a lot of famous quotes and speeches on this. But the idea of this pale blue dot in Carl Sagan's Many quotes on this ultimately inspired actually the name Terradot. So I wanted to end with this as a source of motivation and a reminder of why our work is so important. The name Terradot is Terra for Earth, but also pale blue dot. So we kind of combine those two ideas together. So I'll end on this quote, which hopefully helps us remind us why this work is so important and what drives me personally and all of us, I'm sure, over here today. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of. Every human being who ever was lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines. Every hunter and forger, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supine leader, every saint and sinner in the history of our species lived there on a moat of dust suspended in a sunbeam. Carl Sagan. Thank you very much, and I'm happy to connect after this talk asynchronously, hop on any calls to answer any other questions, or just also learn about all the amazing work that I'm sure everyone here is doing. Thank you very much, and apologies again for not being here live, calling in live from Brazil on the field. Thank you.